Hello, pre-calculus classes. This is Mr. McAllen, and this is day 12 of our flipped classroom for Unit 5. And we're going to work on what are called double triangle word problems because they use two right triangles to solve these problems. The last video was on find the height of a mountain, which used two overlapping triangles. In this one, I'd just like you to take a moment to read the question, and I'm going to pause the video, and then you can play the video after you've had a chance to read the question. Okay, so hopefully you've had a chance to read the question, and it's this balloon that's flying over a lake. So I'm going to just draw a lake. It's like a skinny lake. So it says that the balloon is 3,000 feet in the air. So that would be 3,000 feet. And the balloonist is going to sight the west end of the lake. I'm sorry, first sights the east end of the lake. So let's go to the east. At an angle of depression of 30 degrees to the east side of the lake. And so that's 30 degrees. And 20 degrees to the west side of the lake. So that angle there would be 20 degrees. We know that because the altitude is 3,000 feet, the opposite side of both angles would be 3,000 feet. And what we want to do is figure out what the width of the lake is. So that's going to be found by finding, let's just call this, we'll call this adjacent side 1, and we'll call this adjacent side 2. And we basically have two right triangles and two right, basically right triangle trig you do on two triangles. So we're going to set up the first equation. We're going to say that the tangent of 20 degrees is equal to the 3,000 divided by the adjacent side. And when we, you just have to flip your diagonals, as we talked about in class many times. And that will give us A2. And likewise, tangent of 30 degrees will give us 3,000 over the first adjacent side, which is to the east. And if we flip diagonals again, A1 will equal 3,000 divided by tan of 30. So all we need to do is use your calculator and compute these values. So we have 3,000 divided by tan of 20 for the amount on the left, and that would be 824243. And then the other one is equal to 519615. And our result is the width is equal to the addition of these two, which would be 13,438 feet, and I guess the decimals would add up to 68. Let me just double check that. I'll do it with a calculator. 8242 plus 5196, just to make sure that I'm in the 13,438, and that looks good. So now we have our next problem, where you've read problems like this in the first couple days, but I'd like you to read this problem. I'm going to pause the video, and after you have a chance to read it, I want you to we're going to see how to figure this problem out. Okay, hopefully you've had a chance to read the problem, and I just have a picture here of two random towers. I just borrowed it from Google Images, and so let's say that we have. I'm going to just draw with. I hope this is. So from the 20th floor, I'm imagining that's the 20th floor. An observer sights the top of the tower oops, the top of the tower that they can cite to be, and that's 60 degrees. And there's a 20 feet in between, or 20 meters in between towers. So 20 meters, sights the top of the tower, and then also sights the bottom of the tower. And that angle there is 50 degrees. Now this picture doesn't really look like it's to scale because, 60 and 50 degrees are about the same. So this will be, I'm going to call this H1. And this will be H2. So again, we have two right triangle problems that when we add H1 to H2, we should be able to find out the height of the building. Now remember, the first triangle, the one with 60 in it, we know this is 20 meters, this is 60 degrees. You should be able to find H1. And our other triangle, that's an angle of depression. And I hope I wrote angle of, oh, I did write angle of depression because when you're looking down, that's angle of depression. And this is 50 degrees here, and it's 20 meters, and this is H2. So what I want you to do is, using your trigonometry, solve for both H1 and H2, and let's see if we get the same answer. I'm going to pause the video now. You should be able to do this on your own with that setup. So I'll pause the video, and when you come back, you'll see the answers. Hello, class. We're back, and hopefully you had a chance to work this problem out. And it definitely seems out of proportion with the scale of the drawing, because I just kind of made up the numbers as far as for what the angle of elevation depression would be, but you get the general idea. We show here that H1 for the top triangle should be 34.641. We're going to use a tangent ratio of 60 degrees. And then that equals H1 over 20. We solve. You guys have done this in class. And then tangent, for the second one, we use tangent of 50 because it's our lower triangle. And the opposite side is H2. And when we solve for H2, we get 23.8 meters. The final answer is 58.476 meters. So what I'd like you to do is into the video, and hopefully that helps. Hopefully the volume came through, and just in case, I think my video may have paused by accident. So again, here's a solution, and I'm going to now pause the video so that you can try this word problem that I put down on your own. Okay, class. Well, we have a blimp flying overhead. This problem is very similar to what we had for the first problem. So hopefully you can write it down, and I suggest that you draw a picture of it and try to model the solution to this problem after the first one that we did. And please submit your forms as far as how far the beach is from the high school on the form that I include with this video. I hope this helps, and look forward to hearing your comments tomorrow in class.